Hello again. This is the second video for section 4.1, Advanced Geometry. This is where we're going to work through the examples and talk about what, just applying some of the theorems and stuff from the first video, the notes. So in this first example, question number 11 on the left here, it says, find the value of x. All right, you have a right triangle. The corollary that we just talked about in the last video is that if you have a right triangle, the other two angles are complementary. So x plus 2x equals 90. That's 3x equals 90. That means x equals 30. Okay, now the other part of this question is classify the triangle by its angles. We have one right angle. That means this is a right triangle. Okay, so there's two parts to the question. Solving for x, classifying the triangle by the angles. So for the middle example here, number 12, you just got three angles. Okay, all three angles of a triangle add up to be 180. So you got 2x plus 3x plus 55 equals the 180. That's 5x plus 55 equals 180. Just solving for x. So subtracting 55, that puts us at 125. Divide by 5, x is 25. Now, if x is 25, you plug them back into the angles. That means that's going to be a 75-degree angle, and this is going to be a 50-degree angle. So, to classify this triangle by its angles, all three of these angles are acute. That means this is an acute triangle. And the last example here on the right, x is an exterior angle. We extended this side out, and it's the angle formed by that extension to the next side of the shape. So the exterior angle equals the sum of the remote interior angles, or the other terminology is non-adjacent interior angles, which is 50 and 70. So x equals 120. Now, what kind of triangle is this? So we got one part of our answer. If x is 120, that makes this interior angle 60 degrees. And again, all three angles are acute, so this is another acute triangle. Okay. The next one says solve for the variable. Well, we just did this one, essentially, with that last example. Angle y is an exterior angle. It equals the sum of the remote interior angles. So y is 158. All right, this one, same setup. This is an exterior angle. These other two ones are the remote interior angles. So that exterior angle equals the sum of the remote interior angles. All right, so on the right side of the equal sign, we got two x terms. Let's combine those. And we got a 6x minus 7. I'm going to move all the x's onto one side of the equal sign and the numbers onto the opposite side. So 5x equals 110. X will be 22. And that's all it wanted, was to solve for the variable. And that one's done. Okay, solve for x and for y. So we got a couple of things going on here. So I'm going to start by looking at this one triangle. Same idea with those parallel lines cut by transversal. When you had a bunch of them, you cleaned up the picture, concentrating on just the parallel lines in a single transversal. So I'm going to do the same idea. We got a couple triangles here. Let's just concentrate on one. Something like this. There's that right angle. This was angle x. This one was angle y. So we do know x plus y is going to be 90 degrees from that corollary. That's not very helpful because we don't know either x or y. So let's look at the other triangle, the bigger one. We know the 74, we know the 70. We know something about this exterior angle. It is the y plus the 78. This whole thing is that exterior angle. So we know that y plus 78, the exterior angle, equals the sum of those remote interior angles. All right, so to solve for y, I'm going to subtract the 78. So we got 70 plus 74, that's 144, minus the 78 is going to be 68. There's the y value. Now we can come back up to here. X plus 68 equals 90. That means y is 22. Oh, not y, sorry, x. X is 22. And this is the warm-ups for tomorrow. So that is it. If you had any questions on any of these problems, make sure you're writing those questions down so that you can ask them when you come into class tomorrow. Make sure you're taking good notes. I may be checking those soon. Have a good night.